Hello, this time we're going to be focusing on Industrial Internet of Things, and we're going to look at an IoT deployment map. So we were given four scenarios and then a fifth one where we were supposed to come up with how to deploy an IoT. So the first one was about a home application where you're supposed to count the number of times the door is open, the front door and the back door, and you need to show the map of how the information travels and the layers it'll go through and the protocols and to and from. So for the first layout, the first layer will be the smart lock. That one will be a Wi-Fi enabled smart lock that will can go to from the physical layer, collect the information from the number of door openings and closings based on the door lock itself. And then that information will be sent into your edge device where you can do your edge computing. That way you can you have your own local calculations to do before you send the information into the router. And then from the router you have your you get the stuff to go into the internet using a transport layers. You can use TCP, HTTP, all the way. That will go through the modems, and the internet service provider is the one who will link up your internet system to your MQTT broker, and on their side, that's where the application happens, where you can use their applications to see analyze the data that you're collecting from your sensor, which is the smart lock device at home. The second scenario was about a shipping company which has 7 nodes across the United States, and it goes from Washington all the way to New Jersey. But in between, there's some states. We only have 7, so some states are missing the nodes themselves. And we are given a task where this truck is moving through a preset route, and it should be able to the cargo at the back has a sensor where it checks if it's tilting or it's off kilter, and informs the company. So for this, I went to the gyro sensors and accelerometers on the crates themselves. They're Bluetooth enabled, and then they can talk to the truck cabin itself. And there we have GSM, so we can use our cheap telephone provider because we're just sending data and receiving it. And then from there, it will go to the cell phone services, and then go to the shipping node that we've set up across the way. And from the shipping node, it'll be go to the servers for the company, and on that side, the servers will take care of the information coming through into the cloud itself. The calculations will be done on that side. So as we're going through, we'll be pinging the positions of the crates, and we'll be receiving. It's two-way, so we're trying to send and then receive information back to show that the information we sent was received, and from there we can be able to find out what parts of the network are low or down. And just by looking at the table, we were able to see that New Mexico we weren't able to send and receive, and in Tennessee we were able to send but not receive, and that might be something wrong with the infrastructure in between those places. And if we're going to invest into more shipping nodes, that will be the areas I will put most of the investment towards. And so the next scenario was our agricultural application, where we have some pumps in the middle of an irrigation field, and we have a farm, and it's quite a distance away, and we're trying to monitor the pumps states, where if we want to know if pump 1 or pump 2 is working, or there's drop in pressure, or any of those situations. So we do have pressure sensors on the ground next to where the pumps themselves are working. They're connected to the PLC, and the PLCs themselves are all wired back to the central pump panels. So the panels will build up to one central station, and this central station is where we will use GPRS to send the information over the distance. It's close enough to the farm, so we don't need to go exactly outside or into other telephone provider services other than GPRS. And then from there, we'll place another antenna in the silo in the farm because it's already up high. Then from there, the information will be connected to another local area network, which is at the farm itself. And then from there, it'll go to the edge devices that we have there. We can do internal calculations and then send information back to the field to all the operators out there, the operations manager, and other information can be sent to the headquarters over the HTTP or TCP through the internet into the cloud, and we can collect the data and see it after we receive. And then so it's a two-way because the pumps themselves need to know if they're still communicating with the states, and if something has happened, we can set exactly what state can be done in this situation. This scenario was a lab setup where we were told to connect to measure how fast the RPMs on a mechanical trainer. There's two of them in a lab. The other side was wanted to measure duration of which AC trainers are being used in the lab. We also wanted to see if the 3D printers are open or being used at that time, and we also wanted to be able to talk to someone who's at the door of the lab itself, so you can allow entry or deny entry. This time, as you can see from the map, most of the devices will be stationed next to the machines themselves. So we'll have to utilize the Wi-Fi that's available in the rooms. And then from the Wi-Fi between the mech labs and the mech room, it'll go to the main router where it's in the maintenance room. And then from there, it'll go through fiber optics using to the main servers of the college, and then there we can be able to, now that it's in the cloud, we can be able to access it using just a browser and on the phones or the laptops, and it gives access to the instructors who want to know, and the lab technicians and the administrators of the school network. So for the fifth scenario was pick your own, and so I decided to do a wearable device, a simple application that can actually improve safety in a warehouse or any work environment. This time it's just a simple device, works on Bluetooth, and you can actually place it on the scanners that warehouse workers are using. All it does is just give real-time GPS information, and then we have the MQTT broker who receives all this published information, and then based on the information where the workers are, you can send out publish new information for what needs to be done. So it'll be fairly simple, and it'll improve COVID-19 safety within the facility itself. So how does that one work? So we have the GPS locators inside the scanners themselves. It tells the position, goes via Bluetooth, and goes through internet protocols down to the network into the MQTT in the cloud themselves, and then that one, the broker will take the published information, and then if there's two people who are close to each other, then that's when it'll publish a prompt on what to do if those things happen, and then it'll come back, and this time it'll be going through the wired local area network, and that will beam the system, where it'll inform the supervisors, flash some lights, turn on some bells and alarms, and the scanner itself will flash lights, vibrate, or give the worker a signal telling them they're actually practicing risky behavior by breaking the 6 feet rule. And it's just another layer to just change the behavior and keep the infection from spreading within an enclosed facility. That is it for industrial internet deployment maps, and thank you for listening.